right, so homework 7.2 part 2. Remember I said yesterday the first page is kind of like a review from part 1, so we're just going to do one of the graphing ones. What are some good numbers I should plug in to graph? Awesome. -1, 0, 1, and 2. So when I plug in -1, this is 3 times 1/2 to the power of -1. What does a negative exponent do to this number here? It flips it. So what does it flip it into? What does it become? 2. Instead of 1 over 2, it becomes 2 over 1. And then what's 3 times 2? 6. So what would my point here be? -1, 6. Awesome. Now we do the same thing, but we're going to plug in 0. So 3 times 1/2 to the power of 0. What is 1/2 to the power of 0? 1. So 3 times 1 is 3. So what's my point here? 0,3. All right, and then we plug in 1. So 3 times 1/2 to the power of 1. What's 1/2 to the power of 1? 1/2. So 3 times 1/2 would be what? 3 over 2, which, again, you guys will have your calculator for the quiz. So if you want to put that in your calculator to see what it is as a decimal, it might help you graph it. So it would be 1 and 1.5. Because 3 over 2 is 1.5. So you could just put that in your calculator. And then we plug in 2. So 3 times 1/2 to the power of 2. What is 1/2 to the power of 2? 1/4. Awesome. Remember, it's like saying 1/2 times 1/2. So 1 times 1 would be 1. 2 times 2 is 4. And 3 times 1/4? 3 over 4. Which, again, you can put this in your calculator to see what the decimal version of it because that might help you graph it. So it would be 2,0.75. So let's graph our points. -1, 6 means we go to the left to -1 and up 6. 0, 3 means we stay on 0, go up 3. 1 and 1.5, we go to the right 1, up 1.5. And then 2 and 0.75, we go to the right 2 and up a little bit more than half. So then I can just connect the dots. Remember, your graph is going to be a curve shape. It'll always be curved. It's not a straight line. It should have that curve. If you want to plug in more points to see what else your shape does, you can do that too. So here, do I have exponential growth or decay? Decay. And just by looking at the problem, I can see that I'm going to have decay because this is less than 1. So that number that has the exponent attached to it is what tells us that we have decay. You don't have to. This question didn't ask for it, but it's important to know it for the quiz. Any questions here? All right, and just looking at number 2, is this going to be exponential growth or exponential decay? What's the number that has the exponent? 5. And is 5 greater than 1? Yeah, so this would be growth. So our graph will look like this-ish. But we would plug in numbers to see what it exactly looks like. All right, number 3. So number 3 was kind of a think outside the box type of question. So we have to identify each function as linear, quadratic, or exponential. So remember, something is linear if it's in the form of y equals mx plus b. Something's quadratic if our x is squared, so if it has an exponent of 2. And then something's exponential if our x is in the exponent. So looking at A, what do you think? Is it linear, quadratic, or exponential? Why do you think it's quadratic? Because it has an exponent and that exponent's 2. So if your exponent's 2, that means it's quadratic. Thank you. All right, looking at B. What do we think here? Linear, quadratic, or exponential? Exponential, because x is in the exponent, so this is exponential. What about for C? Linear, because the x is just normal. That's in y equals mx plus b form. This would be linear. And then D? Exponential. Because x is in the exponent. All right, so let's take a look at our word problems. Number 4 says you deposit $1,600 in a bank account. Find the balance after 3 years if the account pays 5% interest yearly. So our formula is a times 1 plus r to the power of t. So I need to figure out what a, r, and t are. So what's our starting amount? 1,600. What's our rate?
0.05.
Awesome. We have to change 5% to a decimal, so 0.05. And what's the time? 3 years. So we plug this into our formula, and then we're going to plug it into our calculator. What do I have to do first here? Add the inside. So 1 plus 0.05 is 1.05. What do I do next? I do the exponent next. So 1.05 to the power of 3. So that should give us 1.157625. But we keep that in our calculator, and what's the last step? Multiply times 1,600. So what do we get as our final answer? 1,852.2, but remember, money is 2 decimal places, so what should I put after the 2? A 0. Awesome. All right, let's look at number 5. An adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases by 25%. How much ibuprofen is left after 6 hours? So we need A, R, and T. What's our starting amount? 400. What's our rate? 0.25. And what's our time? 6 hours. So we plug it in. So we have 400 times 1. What comes next?
1 minus.
Awesome. It's minus because it says decreases. So since it's decreasing, we subtract. So 1 minus 0.25 to the power of 6. So what do I have to do first? Subtract. So 1 minus 0.25 would be 0.75. And then what do I have to do next? The exponent. So 0.75 to the power of 6. So that gives us 0.177978. And then what's the last step? Multiply by 400. So what did we get as our answer? Yep, that works. 71.19, and then it's milligrams here, so we could just put mg. All right, for 6 and 7, it says find the amount in a continuously compounded account for the given conditions. What do we have to do when it says continuously compounded? PERT. Tells us we use our PERT formula. So P times E to the power of RT. So what's our principal? Our starting amount? 2,000 times E, which is just E. What's our rate? 5.1, but is that the decimal of it?
Oh, no, it's 0.51.
So 0.051. And then what's time? 3. So what do I have to do first here? The exponent. So 0.051 times 3. So that would be 0.153. What do I have to do next?
I have to press E and then check the exponent.
Yep, so we do this part next. E to the power of 0.153. So that will give us 1.1653. And then we multiply that times 2,000. So what'd you get for your final answer? So if you're putting it in the phone calculator, you want to put, so in the phone or iPad, you want to put 0.153 and then e to the power of x, that button. Yes, so 2,330.64, which it's 649, so it would round to 0.65. Good question. Because it was 0.649, 9 rounds the 4 up to 5.
Wait, how do you know which formula to use again?
If it says compounded continuously, you use the PERT formula. All right, just for the sake of time, we're going to skip 7 and look at 8. So a coin had a value of $1.17 in 1995. Its value has been decreasing at 9% per year. What is the value after 5 years? So which formula am I going to use? The other one, not PERT. So I need ART. Art. So what's my starting amount? $1.17. What is the rate? 0.09. And what's time? 5 years. So let's plug everything into our formula. I have 1.17 times 1. What comes next? Minus, because it's decreasing. So anytime it says decreasing, you subtract in the middle. So 0.09 to the power of 5. What do I have to do first? Subtract. So 1 minus 0.09, 0.91. And then what do I do next? The exponent. So 0.91 to the power of 5. So 0.624. Just keep that in your calculator and multiply it by 1.17. So we should get 0.73. So looking at number 9, Gina deposited $1,500 in an account that pays 4% interest compounded continuously. What will the balance be in 2 years? So compounded continuously means I use what formula? PERT. So P times e to the power of RT. So I need P, R, and T. What's the principal starting amount for the number 9? 1,500. What's the rate? 0.04. And what's the time? 2. So plug everything in. We have 1,500 times e to the power of 0.04 times 2. So what do I have to do first? The parentheses. So 0.04 times 2 would be 0.08. Then what do I do next? I have to do e to the power of 0.08 in the calculator. So that gives me 1.083287. And then what's the last step? multiply by 1,500. So we get 1,624.93. All right, last one. The Garcias have $12,000 in a savings account. The bank pays 3.5% interest on savings accounts, compounded continuously. Find the total balance after 3 years. So which formula am I going to use? PERT. Compounded continuously means PERT. So I need P, R, and T. What's P? 12,000, the starting amount. What's the rate?
0.035.
So 0.035, perfect, because we take the percent, move the decimal twice, so it'd be 0.035. And then what is the time? 3. So we plug this into our PERT formula, so 12,000 times e to the power of r times t, so 0.35 times 3. What should I do first? Multiply, so 0.035 times 3. So that gives me 0.105. What do I do next? Put in the calculator. So I do e to the power of 0.105. And if you put it in the calculator correctly here, you should get 1.11071. And then the last step, multiply by 12,000. So we should get 13,328.527, but the 7 means that we do what? Round up. So 13328.53. Because since 7's greater than 5, we round up.